So next topic, laws of refraction. Laws of refraction. So the first thing, the incident ray, the refracted ray, and the normal to the interface. The incident ray, comma, the refracted ray, the refracted ray, and uh, the normal, to the interface. Normal to the interface at the point of incidence. At the point of incidence. All lie on the same plane. All of them are the same plane. That's the first point. Second point, the sign of the angle of incidence. Sign of the angle of incidence. Angle of incidence to the sign of the angle of refraction is a constant. That means sine of I over sine of R is equal to a constant. Sine of I over sine of R is equal to a constant. Note number 1, the above constant is represented by n, simple n. Second note, now let's say the light is traveling from medium A to medium B. The light is traveling from medium A to medium B. So this is A and this is B. This will be the angle of incidence I, and this is the angle of refraction R. So here we write NBA is equal sine I over sine R. Carefully look how I write this notation. Here we read this one as refractive index of B respect to A. So look, the light is passing from A to B. So we call this one as the refractive index of B respect to A. Okay. So here, if medium A is free space or vacuum uh, like this, NBA. So we use both the notation. It's okay if you write it above or if you write it below. Both of them are correct. But the side is important. What you write to your right, what you write to the right of N is the refractive index of that medium with respect to the one on the left. If medium A is free space or vacuum, then we can write then NBA is written as NB. We just omit that A. You're telling NBA like this, Najima. Written as NB, and it is known as, it is known as absolute refractive index. Absolute refractive index of medium B. Okay, Najima, that was an Indian video, okay? So their syllabus might be like that, but here we use this method, okay? B is on the right and A is on the left. Or sometimes you might find this notation also. So let's go with this notation, okay? So if A is air, okay? If this is air or free space, then we call this one as the absolute refractive index. It has the absolute refractive index. If A is any other medium, then NBA is the refractive index, refractive index is the refractive index of medium B with respect to medium A. Noted? third knot. Now, when we write NBA, NBA, this is equal to NB over NA. The second one. So here, Najima, if A is air, if A is air or free space, then we call refractive index, this refractive index as the absolute refractive index. Okay. If this is something else other than air, then it is the refractive index of medium B with respect to A. For example, now let's say we have a glass block and this is air. When we find out the refractive index N, so this is glass, what can you tell about this refractive index? Is this absolute or relative? Is this absolute or relative? This is absolute. But now let's say on top of glass, we have some water, a layer of water. Now, when we have a light ray that is bending, it will bend at a different angle. Now, the refractive index between these two, it is NGW. So this is not absolute, but this is relative. It is the refractive index of glass. It is the refractive index of glass with respect to water. Did you get that idea? Okay, has everyone noted up to the third one? Once you have noted up to the third, let me know. Now we have two mediums. Let's say medium A and medium B. And the light ray, it falls at a certain, or it is incident at angle theta 1. So this is incident at angle theta 1. And it is refracted at angle theta 2. How should I write the equation? We should write NBA because it is going into medium B from A. Therefore, NBA is equal sine theta 1, that is the incident angle, over sine theta 2. But I could write this one as NB over NA. This is equal sine theta 1 over sine theta 2. And I will write, I'll just cross multiply them. When I cross multiply them, I get NA sine theta 1 is equal NB sine theta 2. And do you get something here? Look, theta 1 is the angle on the side of A. And theta 2, that's the angle on the side of B. Here also, we have got A and theta 1 on the same side, B and theta 2 on the same side. So, here, I can write this one as n into sine theta is equal to a constant. n into sine theta is equal to a constant. So this will be the most convenient way of Snell's law. This will be the most convenient way of Snell's law. So if you can remember, in your chemistry, you might have studied P1 V1 is equal P2 V2, right? And we also could write this one as PV is a constant. Remember, just like that. When you have the same parameters on the same side, you can just put them together and make it a constant. Okay. Is the note 4 clear? So this is a form of Snell's law. Mentioned below, form of Snell's law. Once you're done, let me know. As we discussed earlier, why light refracts? Light refracts because in different medium, we have different speed. In different mediums, we have got different speeds. So the refractive index, it also should be able to be represented in terms of velocities, right? So note number 5, the refractive index, the refractive index can be expressed in terms of velocity, of light in each medium. So let's say this is medium A and this is medium B. If the light is incident at a certain angle, theta 1, and refracted at a certain angle, theta 2, let's say the speed of light in medium A is VA and speed of light in medium B is VB, then we can write NBA is equal velocity in B over velocity in, velocity in A over velocity in B. We compare the speed in the previous medium with the new medium. So just remember, we go with the same order. A is above, B is below. So what if A is free space? That means VA is equal to C. What is C? C is the speed of light in free space. Speed of light in free space. Then we can rearrange the equation as NB is equal C over VB. Why did I omit A? Now it's the absolute refractive index. Okay. Here up to this. And have you noted? The final note. After that, we can discuss some questions. Note number 6. If anyone miss any note, let me know. Okay, I will scroll up. We know that we can write NBA is equal NB over NA. And this is also equal to 1 over NA over NB. Agree? So this one could be written as 1 over N A respect to B. So we get a relationship like NBA is equal 1 over NAB. See if you got it. Saira and Najima. Okay. Yeah, Najima, what we have done is, are you clear? These two are similar. 1 over NA over NB, that is NB over NA. So this one, how we should write? The one term on above, it is the refractive index with respect to the term below. That is here. Sorry, there is one more note. I just missed one. We can write NBA, we can write NBA is equal VA over VB. And this also could be written as frequency into lambda A over frequency into lambda B. What can you tell about the frequency? Will it change? No, right? It's constant. So just cancel off those frequency. Now we get an equation in terms of wavelength. Done. Let's try this example. Example 1. The speed of light in free medium or the free space is given 3 into 10 to the power 8, and the refractive index of water is given, we have to find what's the uh, velocity of light in water. Can you give a try? So I'll do it on the screen. You'll try by yourself and then check. If I got the same answer, you can just use the raise hand and show. If you find it convenient to put a message, drop a message, or if you find raise hand is easy, use the raise hand. Okay, the second example. You have to find what is Vg. Again, this is light and this is air. Done. Did you get Vg is equal to 2 into 10 to the power 8? Here, the question is you have to find what is the velocity of light in glass. You have to find what is Vg. Ng is 3 by 2. Three by 2. It's 3 by 2 because refractive index of glass is 1.5. Sorry if it was not clear. Done. Najima, okay. The second example. So example 3, the refractive index is given. The refractive index of medium 1 is 1.2. The refractive index of the second medium is 1.5. And the speed of light in second medium is 2 into 10 to the power 8. So these informations are given. What you have to do is you have to complete the ray diagram. Complete the ray diagram and find V1. So how to complete the ray diagram? What you have to do is you have to draw whether this light ray is going to deviate towards the normal or away from the normal. What can you tell? Will it deviate towards the normal or away from the normal? Yes, Simran. So continue. Try it or use it. Yeah, it's towards the normal. Okay. What is the reason? This is more dense. This is less dense. So it's moving from rare to dense. Rare to dense means towards normal. So the light ray, draw like this. Draw the uh, unaffected ray with dotted line, and then draw the refracted and find what is V1. Uh, 1.5. Yes, sure, that's the answer. Imla, it's 1.5. Yeah. The next example. The refractive index is 1.5. This is air. And here the wavelength is 600 nanometer. And you have to find what is lambda. So don't use the equation we derived for lambda. Go from the general equation. Okay. N is equal the ratio of the velocities. Start from there and find out the answer. Once you all have found what's lambda, let me know. So here, this is air, and the other one is refractive index 1.5. So we can write the equation straight away as absolute. Uh, Example 4, Najima, which one? So N is equal C over V. Okay, speed of light over the velocity. But we can write this one in terms of lambda, right? So I'll write as lambda naught over F lambda. Will the frequency change? The frequency will remain the same. Therefore, we get an equation N is equal lambda naught over lambda. So from here we know we know N, that is 1.5, or 3 by 2, which is equal 600 nanometer over lambda. So when you simplify, we get lambda is equal 400 nanometer. Got this answer? Najima, where did you get stuck? Shaira, how about you? Najima, okay. Okay, the meeting might end. Here, what you have to do